Hi friends, welcome to B.Tech. Today I want to discuss about traditional block cipher structure. Cipher means it is a procedure to implement network security. So how the cipher will apply? By using traditional block cipher structure. How the algorithm will be saved? How the algorithm will be implemented? We are taking one algorithm and we are converting or we are inserting it into a block. So within the block, everything will be executed. And coming to a block cipher is an encryption decryption scheme in which the plain text will be converted into ciphertext. So how the ciphertext will be converted? By using any one of the algorithm, we are converting plain text into ciphertext. And also for conversion of the ciphertext, we need one key also. So here we are taking plain text and key. Both of we are using these two and we are finally generating ciphertext. How this ciphertext will be generated? In this block cipher, pistol cipher model. By using this pistol cipher model, we are developing many block ciphers. Almost all in our network security, all the algorithms comes under block ciphers. How to convert a plain text into ciphertext? Here we are taking a plain text and we are converting it to ASCII values. After that, we are performing some operations on those bits. Finally, we are rearranging and you are converting a plain text into ciphertext. So how to work this pistol structure? I will discuss one by one. So first let me show that structure of the diagram. So this is a traditional block cipher structure. If you observe this diagram, this is the plain text. So the plain text is taking and we are forming in a block. So this is a one block. Initially we are taking some plain text. Maybe it is a 16-bit, 32-bit or 64, anything as our wish. That depends on user requirement. After that, you are taking the plain text, you are inserting into this block. Now divide this information into equal parts or two halves, that is left part and another one is right side part. Now you are taking the left part and you are taking the right part. Here you are taking keys. So here I am taking one key and I am applying in this pistol structure. So where K is the key, R is the right hand side of the data. Here I am taking the plain text and that divided into two parts. So one is left part and another one is right hand part. Now I am taking the right side of the part, that is plain text. R means right hand side plain text. Now here I am using f of kr. Here f is any function. It is a mathematical function. By using any mathematical function, I am taking the key value and this right side of the plain text. So first I am implementing the text and the key on this function. Now I am applying XOR operations of left hand side text and this functional keys. So after performing this operation, XOR operation, the left part comes to right hand side and the right hand side part comes into left hand side. So this process is called swapping. So in our normal programming languages, swapping of two numbers, that means we are changing the positions. A position is shifting to B, B position is shifting to A. In similar way, here also we are swapping left hand side plain text into right hand side plain text into left hand side. So the first round is completed. Now second round. In second round also again the same process. Left hand side there is some text, right hand side is another text. Again I am taking the right hand side and I am using second key. So each and every round the key value will be changed. So key value is I am changing and I am using the same function f of kr, where k is key value and r is the right hand side of the plain text. Now I am applying the function and I am taking here XOR operation. Almost all in our network security functions, almost all XOR operations will be done because to break anything it is very impossible. That's why we are implementing XOR. So again we are performing XOR operation with right hand side. So after performing, again I am swapping left hand to right hand side to left hand side. So we are repeating this process until n value. So maybe some block ciphers n value is 16, some algorithms it is 8, sometimes it is 32. So that depends on the number of rounds. So n value is sometimes 8, 16, 32. That depends on given plain text size. So this is a feature structure. So every block cipher algorithm, it follows this feature structure. So dividing the plain text and applying any function value by using any one of the key, and every time you are implementing number of rounds. That means here n value is 8. That means you are encrypting the data 8 times. If n value is 16, you are encrypting the data 16 times. So when you are performing this operation, your data is more secure. Finally, after completion of all the rounds, you will get this ciphertext. And the decryption is also, the total process is called encryption. This is the encryption process. The decryption process is reverse process. So we are taking cipher block and we are going to reverse process. Finally, you will get the encryption. Now the same thing here I wrote. So divide the plain binary text into two halves. If it is a 16-bit, you can split into 8 plus 8. If it is a 32, 16 plus 16. Now generate random binary keys K1 and K2. Here each and every round the key will be changed. For suppose in round 1 the key value is 5. Round 2 K is 10 value. Randomly we can change. Then only our plain text will be safe. So here we are generating key value K1, and the first round we are using this operation XOR of R1 K1. Now you are shifting into L2 R2. So in previously I have explained in the diagram. So once you are taking the right hand side part and you are performing any function, after that you are doing XOR operation with the left hand side part. So left hand side plain text and right hand side plain text. So after that I am performing again XOR function of F1 and L1. So in this way, so this is the round number 1. First round is completed. So repeat the same procedure for second round, third round, fourth round, and so on. So that depends on plain text size. The rounds will be dependent. Some algorithms they will use 8, 16, 32, 128 also sometimes we will use. So we are repeating the same process up to the last step. So finally you will get the ciphertext. So in this way, every block cipher technique, it will use this Fistel block cipher. So this is very, very important. Now I will explain the block cipher design principles. So when you are working with any block cipher algorithm or any methodology, you should take care about all the things. The first one is the block size. What is the block size? So already I said the block size depends on the plain text. If the plain text is low, the block size will be low. If my plain text size is 50, then I can split that block into two parts, 25, 25. And key size, here key size is, what is the key size? How? That depends on plain text. If the plain text is 50, so the key size is also high. None. Third one, number of rounds. How many number of you need to generate? Sometimes if the plain text is very small, then you can implement 4 rounds. Sometimes if the plain text is high, then you are implementing 8 rounds. Sometimes the plain text is very, very large data, then at that time you can implement 16 rounds also. So the major thing is plain text. So the key size, number of rounds, everything depends on plain text. Subkey count. Subkey count means initially I am taking value K1. So after that I am taking K2. So continuously I am taking Kn values. So all these are the subkeys. These are also depends on the plain text. And round function, how many rounds you want to perform, that depends on the functional values. Finally, the plain text is divided into two halves. In this way, these are the design principles of the block cipher. What is the block size? What is the key size? How many rounds you want to implement? So the all the questions single answer plain text. Depends on plain text. You are providing number of blocks, number of keys, and a single function and number of subkeys. So in the next classes we will discuss about different block cipher algorithms.